Hi everybody, my name is Fahn. I'm an application engineer working for Systematics, which is the Israeli distributor of MathWorks. My talk today will be about deep learning, and I'll present to you a practical approach for doing deep learning in MATLAB. So we all know that deep learning is a type of machine learning that performs end-to-end learning by learning tasks directly from images, text, and sound. And we also know that we can achieve state-of-the-art results with deep learning for problems such as regression, classification, object detection, and so on. And you see here on the slide the decrease of the error rate in the famous ImageNet image recognition challenge. You see the decrease over the years. So we have a very powerful tool in our hands, but there are a few challenges that we face when we try to use this tool. First of all, we need to handle and label large amounts of data. Many times we want to accelerate things, we want to make the training process faster, we want to make the inference faster, and we want to use additional hardware resources for that. That can be GPUs, but it can also be clusters, or clouds, and so on. And not many of us have the experience that allows us to use this extra hardware. Another issue is that we need visualization tools and debugging tools that will help us in the rare occasions where things don't work out the way we hoped they will work out. We don't always need to develop new neural network from scratch. We can take an existing network that someone has developed, a pre-trained network, and just modify it so it will be able to solve the problem that we want it to solve, and not only the original problem that it was meant to solve. But in order to do that, in order to do this transfer learning, we need an access to these models and a way to modify them. That's a challenge. And the last challenge I'm going to discuss is the deployment. We usually don't train neural network just for them to run on our local machine. We want to deploy it, we want to send it to run on a different machine. I mean, it can be another desktop machine, it could be an NVIDIA GPU or a CPU from Intel or ARM platform, Xilinx FPGA, clouds, enterprise servers, you name it. And most of us don't have the knowledge and the experience that will allow us to do that easily. What I'm going to show you in the next few minutes is that MATLAB makes deep learning easy and accessible more than ever. MATLAB, which is the technical computing environment developed by MathWorks for the last 35 years, this software has really powerful deep learning capabilities that have been added to it in the latest releases. And you can enjoy these features and do really great things, whether if you are new to the deep learning area or, of course, if you are an experienced engineer. So regarding handling and labeling large amounts of data sets, if you're dealing with images, then you can use the image data store command that will allow you to handle the large amounts of image files that you probably have. And regarding labeling, you can use the image labeler app and the video labeler app that we provide. I will show you them in a minute. So the image labeler app allows you to easily label your images. Here I'm labeling cars in one image. I will soon move to another image and label it. And of course, I can create a multi-class detector. So now I will label traffic signs and not cars. And each class, each label is coded with a different color, of course. And this is how I handle images. If I have a video file, then I don't need to label every frame independently by hand. I can just label one frame, the first frame, for example, and track the object that I've just labeled in the following frames. So I can define the tracking algorithm that I want to use. It can be something that MATLAB provides, or it can be something that I've designed myself, and track the objects in the following frames. This will allow me to create detectors, like you see here on the left side. That's an RCNN object detector. But what if I want to detect things at a pixel level, like you see here on the right side? What if I want to find each pixel that I can drive through without hitting anyone. That's the green pixels. And what if I want to find the pixels that describe cars, like you see on the blue with the blue pixels? So in order to create a pixel level detector, I need to be able to label my data at a pixel level. And both tools that I showed you earlier allow you to do that. Here I classified the street, the road, and the pavement at the pixel level. I used polygons for that, but I can also use brush or float fill operations that will make things faster. So I discussed handling and labeling images, but of course, if you're dealing with audio files or other signals, then you can use the audio data store to handle all the audio files that you have. And we have the audio labeler that allows you to label your audio files, and also we've just shipped the signal labeler. Regarding the second challenge, acceleration of deep learning training. So with MATLAB, GPU computing is the default. You don't need to do anything special if you want to train your network or do inference using the GPU. If you want to use the CPU for some reason, then you just need to set a setting that I will show you in a minute. So other than using a single GPU or your CPU, you can also use multiple GPUs on your local machine. You can use a cluster that has a few GPUs, and of course you can also use a cloud of GPUs. And similar to the addition of GPU computing power, you can also add CPU computing power. And the setting that you need to set in order to select the environment that your deep learning algorithm is using is this, the execution environment, settings, that's the parameter, and the training options function. So if you set it to auto, then it will use your GPU. Unless you don't have an appropriate one, then it will use the CPU. You can set it to use multiple GPUs, or you can set it to use the parallel profile that you are using, and this way you use the other options. One thing to note is that the training in MATLAB is already fast. You don't need to do anything special for that. You see a comparison between MATLAB and TensorFlow. MATLAB is 4x faster than TensorFlow, and you have all the parameters at the bottom of the slide. Visualization and debugging. So MATLAB has always been a great tool for visualizations and debugging, and also in the deep learning we have some very powerful tools. First of all, you have the training accuracy plot that shows you the training as it's progressing, and you see if the accuracy increases over time or not. You can create deep dream images. You can see the network activations, and here we see a channel that reacts positively to eyes and mouth. You can see the features. You can create advanced confusion matrices. You can design your network with a graphical user interface. You don't need to code anything. You don't need to write commands. You can drag and drop layers and connect them using this graphical user interface. And you can then send your network to the network analyzer that analyzes your network, and it can also analyze networks that you have imported from other environments, such as TensorFlow, Keras, Caffe, PyTorch. It analyzes your network and tells you, before you start the training, it tells you if there are unconnected layers, or if there's a data size mismatch or data type mismatch. And this is really cool, in my opinion. Regarding accessing models that are out there in the community. So first of all, you can load all of the state-of-the-art models with a single line of code to MATLAB. You just type AlexNet, and you get the AlexNet or VGG16, 19, and so on. And if you found a network written in TensorFlow or Caffe or PyTorch, then you can import it to MATLAB with a one line of code through the ONNX, Open Neural Network Exchange format. And you can also export your work from MATLAB to these environments. Last challenge, deployment. So with MATLAB, you can compile your trained network and send it using the MATLAB compiler to another desktop machine. You can use the MATLAB production server that will help you deploy your network on an enterprise system. MATLAB Coder helps you to get C code out of your MATLAB code and deep neural networks. And the GPU Coder helps you to get CUDA code out of your MATLAB code. Not only deep learning, but also MATLAB code and image processing and computer vision. A typical workflow that we see is that people import networks from other environments, other open source environments, or design them themselves in MATLAB, and then use our code generation techniques in order to target Intel CPUs or ARM platforms or NVIDIA GPUs. And they do that because they get a significant speed up. MATLAB is faster than all of these Python-based environments. And you see here the GPU Coder results in yellow, the framework that you can achieve for 3 different architectures. You see MATLAB is faster than TensorFlow in blue, PyTorch in green, and MXNet in gray. And this applies not only for desktop machines, desktop GPUs, also for embedded targets such as Tegra, Jetson, TX2, and you see here some of the benchmarks. And this is also done with less memory consumption than, for example, TensorRT. You see the orange line here. For small batch sizes, MATLAB is faster than TensorRT. So I don't have the time to discuss the entire suite of capabilities that MATLAB has for deep learning. I didn't have time to talk about the ability to create your custom layers, the data augmentation capabilities, and also the cool hyperparameter tuning features that helps you to find the optimal hyperparameters for your network. MATLAB supports the complete deep learning workflow, beginning from accessing your data, labeling it, training using additional hardware, and then deploying, as I showed you. This is why I said MATLAB makes deep learning easy and accessible. You can see some of the user stories on our website. This is from Israeli Aerospace Industries. This one is from HP, and there are many more you can find on the web. We invest a lot in this area. Every release that we ship has many, many new features that we add to our deep learning capabilities portfolio. We've just shipped our 2019A. This is our first release for this year. And this release has reinforcement learning capabilities, a new toolbox. And we've added more detectors and networks that you can use. Gartner, which is an independent consulting and research company, just recognized MathWorks as a visionary and one of the top data science platforms, one of the top deep learning and machine learning environments. You see, this is from January. We are very thrilled and excited to get this kind of recognition. If you want to know more, you're more than welcome to visit our Deep Learning in MATLAB website, and you can try our free hands-on. You go to matlabacademy.mathworks.com, and you can try our deep learning capabilities for free. It's a 2 hours or 3 hours tutorial. You don't need a MATLAB license for that. You just need to log in and web browser. And for more information, you can visit our blog, MATLAB with Fahn. It's in Hebrew. The LinkedIn group, MATLAB and Simulink users in Israel. And you can reach out to us out there in the booth, and also at the telephone number that you can see here at the bottom left. And last thing, we have a big conference coming up in May, MATLAB and Simulink Expo. It will take place at the Hilton. It's free of charge. You just need to register. So I hope to see you all there. Thank you very much.